All right, let's jump right into this explainer. Today, we're looking at a truly fascinating legal defense, one that actually uses quantum-level physics and network topology to fight a social media charge. We're breaking down the case of Dr. Chen Jingyuan. He was facing a massive criminal accusation, specifically that he caused severe disruption to public order with just a single retweet. But instead of going with a standard legal defense, Dr. Chen submitted this incredibly unique document from prison. He totally bypassed normal legal arguments. Instead, he used the hard, immutable laws of complex system science, computer science, and physics to completely deconstruct the prosecution's logic. It's a brilliant, completely impartial look at what happens when the rigid, traditional language of the legal system literally collides with the chaotic, nonlinear reality of modern digital networks. So, we have to start with this profound question because it perfectly captures the high stakes of Dr. Chen's case. Can a single post from an account with barely 100 followers actually disrupt an entire society? The prosecution said, absolutely yes. They argued that retweeting sensitive info directly elevates the risk of societal disruption, making his single action legally responsible for public chaos. But Dr. Chen, looking at this through the lens of hard science, asks us to measure this objectively. Think about it. If a user with less than 100 followers floating in a vast sea of billions of daily data points clicks share, does the physical architecture of the internet even allow that tiny, isolated action to collapse the entire system? To answer that, we have to look at how different these two worlds are. The traditional legal system relies on a very Newtonian, linear worldview, right? Action A directly causes result B. You push a domino, it falls over. Simple. But science tells us that a social network is what we call a complex adaptive system. It doesn't work like falling dominoes. It operates through emergent behavior, high entropy, and nonlinear dynamics. In a complex system, you can't just blame macro-level outcomes on a single micro-level action because the system itself is constantly shifting, constantly self-organizing. Dr. Chen explains this core argument with this incredibly simple, memorable metaphor about the scale of individual actions. It really highlights the absurdity of what's called a structural attribution error. Look, yes, breathing releases carbon dioxide. And yes, carbon dioxide contributes to global warming. But prosecuting one single person's breath as the direct cause of climate change, that's a massive category error. Dr. Chen argues that prosecuting his tiny, microscopic social media footprint as the direct cause of public order chaos is the exact same scientific fallacy. Okay, moving on to Section 1, Law versus Complex Science. The crucial point here is that a social network is inherently a high-entropy, chaotic system. That means disorder is actually a structural norm, not some weird anomaly. The law kind of operates on this assumption that society and a social network is this calm, perfectly orderly lake, and an offender is someone who throws a rock in and creates disruptive waves. But complex system science proves the network isn't a calm lake. It's a boiling pot of water. The turbulence isn't a crime. The turbulence is literally the natural physical state of the medium. Let's look at Section 2, the CAP theorem, and why order is impossible. To really understand why this disorder is normal, we need a quick lesson in computer science. Back in the year 2000, Eric Brewer formulated the CAP theorem. It proves mathematically that a fully ordered, globally consistent digital network simply cannot exist if it wants to stay online. Let me break that down. A distributed system is basically any network spread out across multiple computers, like say a social media platform. The CAP theorem says you can only ever have two of three things. You've got consistency, meaning everyone sees the exact same data at the exact same moment. You've got availability, meaning the system is always online to answer you. And partition tolerance, meaning the system survives even if parts of the network lose connection with each other. In the real world, network breaks, or partitions, are completely inevitable. So platform designers always have to choose between consistency and availability. And guess what? Social media platforms universally choose availability. They want you online all the time. Therefore, mathematically, they have to sacrifice absolute consistency. This means asynchronous updates, differing data, and a baseline level of informational chaos are literally engineered into the fabric of the system. Dr. Chen argues that the justice system is effectively trying to criminalize an unavoidable technical reality. All right, Section 3, Scale-Free Networks Explained. Since we know these networks are inherently messy, we have to look at how they're actually built. Social media platforms are incredibly unequal ecosystems. They're heavily skewed toward a tiny minority of super users. In network science, which was pioneered by physicists like Albert Laszlo Barabasi, a scale-free network is dictated by a power law. That means the vast majority of the network is just edge nodes, regular people with barely any connections. Then on the totally opposite end, you have hub nodes, major media outlets, celebrities, massive influencers with millions of connections. The entire structure of the network depends on those hubs, not the edge nodes.
When we look at this ecosystem, Dr. Chen's account is just a tiny edge node completely lost in the vast background noise of the internet. With fewer than 100 followers and almost zero interaction history, his account is mathematically insignificant to the network's overall topology. If a hub node posts something, boom, it reaches the entire network instantly. If an edge node posts, it reaches almost nobody.
Let's dive into Section 4, Robustness and the Edge Node. So exactly how much damage can an edge node actually do? Well, Cohen and Shlomo Havlin's critical threshold formula reveals a pretty mind-blowing mathematical fact about scale-free networks. They calculated exactly how many nodes you'd need to remove to make the network collapse. And their formula found that the critical threshold, P sub c, approaches 1. That literally means you have to remove almost 100% of the randomly selected edge nodes before the network's structural integrity even begins to notice. Because the system is so overwhelmingly dominated by those massive hub nodes, the actions of a single edge node are mathematically incapable of causing a system-wide collapse. These scale-free networks have extreme robustness against random blips from edge nodes. Dr. Chen points out the completely logical conclusion here. If deleting his account entirely wouldn't even register as a tiny blip on the network's radar, how on earth could a single retweet from that exact same account have the kinetic energy to cause severe public order chaos? It's mathematically impossible. Which brings us to Section 5, why avalanches don't happen. Now, you might be wondering, what if an edge node tries to start a viral chain reaction, a sort of avalanche? Well, the truth is, when an edge node like Dr. Chen posts, the cascade dies almost instantly. The mathematical probability of it actually branching out is just way too low. In complex systems, we model this using a branching process, tracking the reproduction number, which we call M. For an edge node with no algorithmic boost and barely any followers, M is vastly smaller than 1. And when M is less than 1, the signal is in a subcritical state. It faces certain extinction. It's going to die out in just a few steps, completely swallowed up by the network's background noise. Unless the entire social network is already in a rare, hyper-agitated, supercritical state, a single tiny spark cannot start a forest fire. For an avalanche to actually happen, the system's average branching factor has to be greater than 1. And that requires extreme algorithmic amplification, or the coordinated action of massive hub nodes. Dr. Chen argues that if an avalanche did occur, it means the system was already acting like a giant powder keg. Blaming the edge node is basically punishing the spark while completely ignoring the massive, pre-existing structural instability of the network itself. Finally, let's look at Section 6, a paradigm shift in justice. What Dr. Chen has done here is expose a massive gap between the language used in a courtroom and the actual physical reality of the universe. The legal framework is trying to govern the digital world using terms like disruption or presumed risk. These are highly qualitative, subjective labels, but the digital world, it obeys the strict laws of physics and network topology. It deals in quantifiable, mathematical realities. Dr. Chen's defense is essentially a demand for the legal system to get a much-needed operating system update. He argues, totally impartially, that shifting the blame for an inherently chaotic system onto a mathematically insignificant edge node is a fundamental misapplication of causality. You simply cannot apply a linear A causes B legal standard to a nonlinear, complex adaptive system. The chaos is built in. That's the CAP theorem. The lack of individual impact is completely guaranteed by scale-free network topology. Because of those two facts, the direct causal link that the prosecution relies on is entirely severed. The ultimate takeaway from this explainer is that it forces us to reconsider how justice handles the burden of proof in our digital age. Under the presumption of innocence, the burden of proof lies entirely with the prosecution, right? Well, Dr. Chen's defense dictates that it's no longer enough for the prosecution to just subjectively assume a retweet caused harm. They must scientifically prove that the network was already in a supercritical state. And they have to mathematically map the propagation pathway to show that this specific edge node triggered the collapse. Without that hard data, the charge is literally just a hypothesis lacking any empirical evidence. I want to leave you with this final provocative thought to really ponder.
As our society becomes more and more reliant on these incredibly complex, non-linear digital systems, can we really afford to have our legal framework stuck in a linear Newtonian past? Dr. Chen Jingyuan's defense definitely wasn't standard courtroom procedure, but it serves as a fascinating historical marker. It's a moment where physics essentially demanded a seat at the table of justice. It challenges all of us to build legal systems that truly understand the environments they are trying to regulate. Thanks so much for joining me on this explainer, and remember to keep questioning the systems around you.